So let's take another look at the force table here. Force table shows us vector addition. And right now, these three tensions, because I can pull this peg out and it doesn't slide one direction or the other for the most part, means that these three tensions must all be canceling out. This must be in equilibrium. And what I didn't do last time and what I want to do this time is take a closer look at the angles, right? This is 0 degrees here. So again, I can put in the Cartesian coordinate system however I want to. But if I put in the Cartesian coordinate system, right, like this, so that 0 is lined up with 0 over here, then this tension is pretty much up at 90 degrees. This tension here is pretty much at 90 degrees, making him all Y. And this tension over here is at 180 degrees, making him all X. So all X and all Y. And then this is the force that's balancing them. And so, yeah, so the reason there's a tension is because there are these hanging masses down here. And this tension here is balancing those two. So that means this tension here must have a Y component that balances this tension, and this guy here must have an X component that's balancing this tension. So if you look here on the paper, this is what it looks like: tension 1, tension 2, tension 3. I didn't draw the actual magnitudes, but you get the idea. If this one came up and this length represented his magnitude, and then obviously the direction, and this represents his magnitude and the direction, then this force which causes equilibrium would have to be down here. And so this, if I call that vector 1 and vector 2, and this is vector 3 would have to have a horizontal component or X component that was equal to this tension, and vector 3 would have to have a vertical component that would counteract this tension, so that the whole thing was in equilibrium. And yeah, that's what we see. These strings are in equilibrium, and when I pull out this peg in the middle, I mean, a little bit of friction on the pulleys, but other than that, these three tensions are canceling out, and there's no acceleration to the system.